Okay, so hi guys, welcome back to another episode. Now, for the past 1 year, I've spent my time building enterprise AI applications, spanning from RAG applications, simple chatbots, to agent. And there's one very important aspect of building these applications that most people treat them as an aftermath. Yet, these are the first things that you need to consider before you even write your very first line of code. And in an enterprise setting, you will need to answer this question. How do you handle PII data, personal information, sensitive data, passwords, usernames, email addresses, phone numbers, addresses, social security numbers, a number of things, as long as it's labeled PII or sensitive information. Think of it this way. If you're building in finance or you're building in a healthcare ecosystem, these are two industries where there's no compromise when it comes to data handling. In finance, remember, banks, they have to store email addresses, account numbers, social security numbers, maybe credit card numbers, your next of kins. All these are personal information, PII information, okay? When we go to health industry, we have what we call electronic health records, and then we have protected health information. Remember, right now if I'm sick, I go to hospital. Number one, they will diagnose me and take records of what I'm suffering from, whether it's chronic or just a one-time illness. And then they will also have information of my next of kin, like it's kind of a disease that is generational, like I can pass it from one person to another. Let's say if my mom had it, then I can have the disease. This is some information that we won't want like anyone to get access to, including AI. Now, most people build applications and they don't think about the PII aspect of it, handling of data privacy, how data handling actually happens. And this is one thing I've learned while building enterprise AI applications in the finance sector. One, that is the very first thing you need to understand. How are you going to ensure that the AI model that we are using never sees any PII? I've tried a number of chatbots I've come across, and they actually just expose the PII to the AI models, which is very, very bad. That's a crime. It's actually a crime. So in today's session, I actually just want to show us, let's discuss something on how it actually happens. On a high level, we're not going to be writing any code today, just the overview of how this should be handled and how the naive approach does it, okay? So let's get to work. Now remember, this aspect of RAG. So in RAG is basically where we are trying to mitigate hallucinations in AI applications. So basically, we want to augment the AI response with our personal data or external data. So in this case, I'll be having, let's say, I have an external knowledge source here, which can be an healthcare app, finance app, personal OS, something like a personal app. And then now here is me, and I have my question here and it's a message. Now in AI applications, remember, you can type your query and then you get back your response. And in this case, now we have the question here, and then we have the external knowledge source here. And then also we have the AI model. Now remember what happens. What usually happens is, if I type my question here, this question is sent to an AI model. So let's assume here we have our AI model, and let's call it Sonnet 4.6. Sonnet 4.6. Okay, and then also we have something else, another AI model, which is for embedding. Okay, so right here we also have what we call, let's say text ADA002. So inside this we also have text ADA002, or 003, small or large, depending on what you want to use or your use case. So in this case, we're using text ADA002. So two things happens here. One, if I ask the question, that question first has to be grounded or embedded. So I have to send it here to text ADA002 for this question to be vectorized. So once this question is vectorized, the next thing is now we're going to use this embedding or vectors to do a similarity search in our external source of data. So which means from here, the next thing I'm going to do is maybe just come to my external source here and then do what we call similarity search. Similarity search or semantic search. So what happens during similarity search or semantic search? So semantic search is basically where we're going to find or search for chunks which are semantically similar, or then we can narrow down to similarity. After getting the semantics, we can now narrow down back to similarity. Now in semantic, we could use things like the cosine similarity, and then in similarity search, we can use what we call like the BM25 lexical search. So we have similarity search and semantic search. Usually they work hand in hand, semantic and similarity, to narrow down to like the top 5 chunks. Okay, so this will give us back what we need. Hold it there. But remember, before we actually have external source, remember the AI application won't understand our actual content like PDFs in their raw format, the PDFs, PowerPoints, Excels, Word documents. Our AI won't understand them. So we also have to embed them and then store them. So something else that was done before, so that we have this external resource, was the ingestion, which is taking in information and then preparing it for in a format that the AI understands. So when we come here in the question here, now we don't have the question, so we have external source. So what happens here? So here, let's say I have what we call a drive here. Most organizations use what we call the OneDrive to store their documents. So right here I have OneDrive. OneDrive. So OneDrive has PowerPoints, PDF, Excels, it has images. So we need to ingest this to store it in our knowledge here. So this, you can also call it a vector DB. Let's call this our vector DB. Vector DB, okay? So what happens? We ingest. So we have to ingest here. We ingest this so that we can store it in our vector DB, or what we call now the external data source, okay? Now, think of it. In an Excel sheet that we have in our industry or in our company, it has transactions data. The amount sent from who to who, the duration or the time it was sent, and transaction cost, account numbers, everything is there, right? Or email addresses, account number, they're all there. Most of these are actually what we call PII information. So for example, we could have something like Gen10 sent 5,000 to account number, blah, blah, blah. So we have Gen10, then we have account number, let's say account number KE12345, okay? And then we have something else. What can we have? Social security number, social security number, SSN, okay, let's call it that. Also 7895, okay. So we have Gen10, we have account number, and then we have the SSN number, which is 7895. So the naive approach is basically just to embed everything the way they are and store. But that will then expose our data to the AI models or even to the public. So how do we handle this? Remember, during the ingestion, something has to happen. What happens here is what we call chunking. A document can be as large as 1,000 pages. And depending on the context window of the AI models, we have to work within specific contexts window. For example, you can have like a context window of 1 million, 1,000 tokens, 10,000 tokens, depending on the model you are using. So in this case, if we have a document, let's say it's a .excel document, and it has 1,000 pages. So I'll come here and let's say we have not it there, but here we have .docs that has information about the our clients or customers. So it's 1,000 pages. So the first thing we do is we first scan the entire document before we chunk. First scan it, looking for all this PII information or sensitive information. So once we scan, then we'll come across Gen10, then we'll come across account number and social security number. At that point, so we've already detected that this document actually has some PII data. So what's next? The next thing we need to do is to either pseudonymize or mask them. But I would prefer we pseudonymize instead of masking. Masking will come in later. I'll show you where we're going to mask. So I want you to bring another database in the picture. Separate its own service somewhere. And that will be a relational database or even just a document database. Doesn't matter. MongoDB or Postgres. In this case, let's do Postgres. Okay? So we'll have something here like a Postgres database. Postgres database. So these are just records, okay? Perfect. So what happens? So once we detect that you have Gen10, what do? We take gen10, and then this gen10, let's just bring it to our PostgreSDB here, all this PII information. So we have gen10, and then we have account number and social security number. So we tokenize this information. How do we tokenize? One, we'll give it something like this gen10 is a name, okay? So instead of having gen10 sent to the LLM, what we're going to do here, we're going to have here something like a token which is generated automatically. You have to figure out how you're going to get that token. So it's a name, so we preface it with something like name, then it's token number 456. Then come to account number. Account number is KE1246. So in this case, you can tokenize it and have it like, for account numbers, we preface with SEC, then we say something like 256. Then social security number, we can also tokenize it and then have a prefix of something like social and then 3645. Okay. Once we do this, you can use other libraries, for example, a Python faker for names. Instead of having gen10, we'll have something like Janet Wanjiku. That's not the actual name, Janet Wanjiku. So it's a fake name. And I'll tell you why we're using a fake name, because you just can't use a fake name for the sake. I'll tell you why we're using a fake name. So then, what do? So in our DB itself, we have it stored in the actual values the way they are. So we have name 456, which is gen10, and its tokens, okay? So this is in the DB. And in the DB also, we have to do encryption at rest. So look for an encryption tool, and then encrypt them at rest. For the encryption, think about that, how you're going to encrypt. Maybe we can do that later in other videos. After which, what we're going to do next is now to replace what we have in the actual values with the tokens. I want this to make sense. We replace the actual values with the tokens and the pseudos. So if I have gen10 sent 3000, so we'll have something like Janet Wanjiku. Let's call it Janet Wanjiku or Janet Momanyi. So we're coming here and now saying Janet Momanyi sent 5,000 to account 256 on social, whose social is whose social is SOC 3625. So I want us to understand something here. Why are we even pseudonymizing? Because remember, if we just use some ciphertext, then during the semantic search, there will be a lot of noise. The LLM won't understand what we're trying to do here. Like, it won't understand our intent. What do we want to search? So this is what we send to the vector DB, which is now here. And then along that chunks, we also store the tokens. The tokens that we want to store in the vector DB also are the name 456, account 256, and SOC 3625. So during the search, it retrieves the chunks plus the tokens. Now, what do we have sent to the LLMs now and embedded? What we embed is actually now just the tokens here, not the actual values. And during the retrieval, it retrieves the tokens instead of the actual values. And I'll tell you how it maps back. So once we have this, which means if we retrieve, we will get Janet Momanyi sent 5,000 to SEC, whose social is SOC 3625. Then at this point, once this is what we retrieve from the vector DB, then what is sent to our LLM for now the coherent generation is something different. What do we send? We send actually this. But instead of sending this, the first thing that happens is we send them to AI, then AI will use the chunks and then just adds its own more text or context. And then before we send back response to the user, we map back. So how do we map back? In the last step, we take Janet Momanyi, and then remember we also stored its tokens. Remember I told you the tokens were stored. So Janet Momanyi is actually name 456. So it maps back. From Janet Momanyi, we go to gen10. So this will be gen10 right here. Gen10 sent 5,000 to account. It gets account 256. We go back to our database. Account 256 is KE12456. So we get KE12456 whose social is SOC3625. We map back SOC3625, which is SSN 7895. SSN 7895. So now you see how it maps back. The NeMo money, which is a pseudo, gets back to actual value, which is Gen10. Account number 256 maps back to KE12456. And then social number, which is SOC3625, which is a pseudo, maps back to SSN7895. Now, this is basically the entire pipeline from ingestion, tokenization, encryption, pseudonymizing, tokenization, and then mapping it back. So the map back to the DB is the last step after the whole generation. And the reason why we are pseudonymizing is because if we just use the ciphertext, which is something very ambiguous, some weird characters, when we send them to vector database, and then I come in and type something like, what is the last transaction that Jane Momanyi did or Jane Manjuro did? Then if we had sold the ciphertext, it won't get any name like Jane Wanjiri. It will get something weird. And that site's going to end up bringing some irrelevant context for us to generate. And that is why if you pseudonymize, it still detects that this is a name. So, which tools do we use to pseudonymize or even detect these entities, which is PII? So we have things like, and the ones that we usually use, I've used a number of times, we have the spaCy named entity recognition tool, library, I mean, or what we call NER. Let me move it. And then you also have Microsoft Presidio tool. So Microsoft Presidio tool. Yeah, these are just two examples of the tools you can use for the detection of the PII or named entities. But there are a lot more tools that you can use. So what I've given you here is just like an overview of how they should be handled to protect the information that is very personal and sensitive. So here is simple and you can implement it on your own. Just find a way in which you first redact or just detect all these PII. Then contextualize them, tokenize the entities. Then when you store them on the database, which is now like SQL or NoSQL, ensure that you've encrypted them at rest. So follow this whole pipeline here, follow the entire pipeline just to get a context or a picture of how next time you're building an application, you don't expose my name. You don't expose my account number, which has 0 shillings in the bank account. You don't expose my disease to the internet or to the AI. If this is useful, then see you in the next video. Oseko Codes signing out.